Good afternoon, everyone. Welcome to our webinar conducted by Marlabs. And let us give 30 seconds for everyone else to join. We'll stay back and join momentarily. Thank you. So welcome back, everyone. Good afternoon. Let's get started. It's 101, and I'm sure a few others are joining. And today's webinar is the AI-driven transformation of software testing. And here is the quick agenda. So we first introduce ourselves, and then we talk about what we're going to cover in the webinar and what is not covered. Then we quickly talk about some of the challenges in the software test lifecycle, and then we talk about AI at a very high level, and then we look at potential use cases of where AI can be leveraged in QA, and we'll talk about one of the players in the market that we are partnered with. So with that said, we'll start with introductions.
Welcome, everybody. This is Raj. I'm the co-founder at Autonomic, also responsible for products.
Good afternoon, all. This is Siva Prasanna Vanapalli, and they quality engineering and the DevOps Marlabs. Just to give you about Marlabs. Marlabs is a services-based company. We founded in 1996, and we headquartered in Piscataway, New Jersey. We are a CM level 5 company. And we are about 3,000 associates across the globe. We have delivery centers based in India, Mexico, Canada, and Germany. And we do enter end-to-end, cover the system integration aspects, and we cover technology solutions from cloud. And we are known in the space from a digital technology solutions provider standpoint. And we also cover end-to-end services, right from application, product engineering, and maintenance, all the way through packaged implementation services. And just to talk about our service, we do end-to-end, we cater to end-to-end software testing lifecycle driven services, right from offering strategic, offering quality assurance to engineering services, as well as some of the top-notch, like DevOps and continuous testing implementations, and automation performance. We also have our own proprietary test automation frameworks built around test automation and open source and commercial tools. And we do quite a lot of consulting and end-to-end implementations with the performance also. That's at a very high level. Take a lot of time on this space. We'll quickly jump on to the current context. So just to give you a context and background about what we are covering and why we are doing this webinar today. With the digital transformation that's happening and a new word in the last 3-4 years, there is a lot of adoption with DevOps, and that is actually fundamentally altering the way in which the release cycles are being released in the especially in the software development lifecycle. And the amount of challenges, Agile and DevOps in the faster cycles have been bringing into the, software development life cycle. It's actually, when it comes to testing and quality assurance, it is shrinking down the window of testing down to 50%. I've spoken to a lot of customers, and there's a common concern that I get a lot, that the time that every organization is giving to testing is actually coming down. At the same time, the velocity is expected to be increased quite a lot. So there's very short amount of time to maintain the velocity. But actually with the arrival of AI, we are looking at a real breakthrough in the software testing where we could maintain or improve the velocity at the same time, bringing down the or accommodate the shorter release cycles that everybody has. So with that said, AI can be leveraged. At the same time, we are not going in detail in terms of which algorithms do we use from machine learning and how AI, different platforms and all that. Our goal is to talk about some of the use cases where AI can be leveraged and how it can be leveraged, and some of the help that we can get with AI. And we will leave it there, and then potentially with a demo from one of the partners that we have. Just to get the problem with QA getting lesser time in terms of overall software development lifecycle is not something new. Ever since we know waterfall, there has always been a pressing need to accelerate the testing cycles. I have, going back to 90s, the initial ways of automation started with nonlinear automation like VB macros or sort of, automation in terms of leveraging XMLs and some code programming automation. But then there are a lot of tools that Mercury and IBM have released their own tools, and tools started playing a bigger role in the test automation. And automation frameworks have also evolved quite a lot. Eventually, when the Agile has come in, the demand for automation has significantly increased with the release of Selenium and other open source tools. And again, the evolved DevOps, where the release cycles have even evolved more, and the adoption of CI/CD in the testing space, in the entire software development space, has created again even more stress on testing, which again came up as continuous testing to ensure QA and testing is part of the Agile and the dev life cycles. So we're happy with it. That actually did a lot, but there is always a possibility of what's next. How do we ensure challenges with continuous testing or challenges, QA in general could be addressed, and how could we, or what are the techniques, some of the techniques that are in the market that could be leveraged? So that's the whole context of today's webinar going to be. It's time for a quick 30. So please all respond to the quick poll that you see on the screen. Just last few more seconds, so please respond quickly. Okay, so we are back. So as you could see, the percentage of test cases that are automated today, under 25 is about 44%. 50% to 75% is where you have, quite a lot of presence. So that actually goes in line with, what we see on a day-to-day basis. Over 75, you could see, is literally 10%. So that's where every organization wants to go, to have I've seen a lot of CIOs setting up internal targets like, half automation, 90% or greater. But if you look at the polls, it's, less than, 10% that matter. So let's back to our presentation. So let's look at the need for, the in the test automation. So the time spent in SDLC, let's take an waterfall example, which is of an year. The initial plan, typically you get about 3 months in a quarter, about 25% for QA. But realistically, this survey is done across multiple internal to Marlabs and also some of ours. We would only see that we get 50% less time. Even in the agile and sprint activities, there's a lot of focus to begin testing and deliver the tickets and close the user stories. About 40% in the first 5 days, and about only 10% in the last. But you always see it quite opposite. That you get to see 40% tickets trying to get closed in the last minute. Banging around the wall and just trying to close in the last minute. About 40% in the last 2 days, which is never ideal. So close to 50% time crunch for QA. Even if you look at it from an effort standpoint, it is very similar. It's both from waterfall agile standpoint, you quite a lot, but the amount of and the effort you get because your time is really short is only 20%. So you get about 30 effort loss or budget loss because of the time you get to focus on it. But if you zoom in further, automation. Let's look at, in a QA automation project, typically you spend initial amount of time in setting a framework, doing some generic functions and project functions. Then you manual and test case designs, and then you do the actual scripting, picking up one of the languages like Java or VB, depending on the tool you choose. And then you start to execute. So there is a cycle that happens. And if you look at the overall time that you allocate, framework design would take about 25% and about 50% between manual and test automation script design, and about 25% for designing. But if you look at main the automation scripting are 3 major activities that takes quite a lot of time, and that's why a lot of organizations fail to keep up with the pace at the release cycles are happening, because there is always a separate team that has to sit and maintain these test cases at any point. Even with coming into into SDLC phase, and the continuous testing made a big way in terms of ensuring that testing is part of CI/CD, continuous integration and continuous deployment delivery. But yet there are certain challenges with continuous testing because of the way or inability to move faster and smarter, higher the number of releases, the number of features. It also takes higher maintenance. And if you do not have even sophisticated frameworks, you still got to identify the changes, make those changes, and changes before you can actually leverage them. And again, in terms of team issues too, DevOps teams are not necessarily on the page with the test automation, and the whole team has to be in sync in order to accommodate the fast release cycle. And there is also so much and test data, and the pace at which things are going and the volume at which output is expected, it is really hard to keep in sync, especially with the maintenance. Besides continuous testing, there are a few other challenges too in quality assurance and engineering space. And there is a lot of digital, with the digital disruption, there is always a question in terms of how many variations a given tester has to test. Cross-platform or cross-compatibility is a bigger question. And the increased code, ensuring the right amount of coverage, according to changes is a bigger question always. So looking at all, right, it is always a question around what's next and how much, could we do and what we could do. So one of the, I wouldn't say, but one of the ways to look at is how could we leverage AI? AI is also one of the buzzwords, and it has taken a bigger space in other aspects. But in the QA space, it has not matured a lot. We have organizations taking conscious effort in terms of leveraging AI in the QA space. We have helped a lot of customers doing the same and some success. Without a lot of details, typically AI at a very high level, the different components, which is natural language processing, anything to do with text generation, reading text, writing text, and that. Machine learning, which is both supervised and unsupervised, different algorithms, and doing a lot of deep learning around it. And also expert, systems that cause, vision, robotics, and speech and all that. So let's focus a couple of minutes looking at where do we do, and how do we leverage AI. Before it's another quick 30-second break for the second poll, just to see where we stand. So you have quick 30 seconds to answer. About 20 more seconds. About 10 more seconds. Thank you. So if you look at the results, primary challenges when it comes to test automation is picking the right tool and framework, and frequent code changes, and of course team skills, because a lot of tools coming into the market, and there is no way for every member in the team to be in sync or to keep up with the challenges that are coming into market. So definitely AI is a great way to leverage, and let's get back to the presentation, and let's look at some of the potential use cases in QA where AI can be leveraged. So I have broken down to those cutting across each phase of the testing life cycle. First one to begin with, test design, covering both the new functionality and the existing functionality. Then with the maintenance phase. Then with RCA and defect prevention, areas. Then with risk-based testing and some UAT and production analysis. Let's talk about each use case. The first use case is how do we design test cases, from an automation standpoint. So you would naturally know there are multiple requirement analysis, then we develop the manual test cases, then we refine it from an automation standpoint, then we create reusable functions, even if you have the framework in place. Then we program it with one of the tools and the programming languages that you adopt. And then you execute those test cases, unit tests, and all that. But leveraging AI and NLP, the three steps that are highlighted in the first use case, like reading the test cases and then creating reusable functions and program it, we could actually leverage natural language processing of AI and could reduce those three steps, bring down from hours to literally minutes. And today's use case is going to show that how, but that's one of the best areas that you can actually really adapt to with a newer functionality. And if you have existing functionality where you want to design test cases, both automated and manual, it's the same process, except that you could actually use some recorder tools to record some of the actions and keywords. That way you can save some time from an automation standpoint. But again, it's the same process, and you could use those about 75% of the time. So with leveraging AI and NLP, you could save about 75% of your time. That's a very good savings. And the second use case is leveraging AI in the test maintenance side. So in a typical maintenance cycle, whenever you find there is a change in the application, you first have to identify the change and identify the test cases that are impacted, and identify what change has to be made. And the next step is to make the change, and the next step is to re-execute and then make sure all of it. But with AI and machine learning, it's a very futuristic and very ambitious goal, but we could leverage with the machine learning algorithms and with the deep learning, we could actually, set the processes in place in such a way that the builds, old and new builds, can be compared against each other and could guide the manual test or even automation scripts to actually design what changes has to be done. In the way it is currently being there, you could also execute test cases on a nightly basis and let the AI highlight the differences and prompt the users to make the changes. So that way, you don't need to maintain the test cases. You can let the AI and ML take care of it for you. Another use case is with defect prevention. We always maintain a lot of defects in one of the test management tools. Every tester conducts the root cause analysis, and we store them in a defect management system. And then we could actually leverage AI and ML to go through those the data that is out there, and then recommend based on the RCA that is done on which test cases to be actually developed in future releases, or which areas to be tested or heavily focused in the upcoming releases. And one advantage is we could always recalibrate those algorithms until we get a refined success, right? So that's another big area where AI could be leveraged in the quality assurance space. And the fourth use case is with risk-based testing. And a lot of organizations have adopted risk-based testing, especially during the time crunch where QA doesn't get a lot of time. With our risk-based testing, few major important aspects is to assign probability and impact analysis for each test case or for a given set of test cases. While it is not possible to execute all test cases in RBT, we could deploy AI and ML to monitor the success criteria with those, with the risk analysis, and then do the root cause analysis for those, and keep recalibrating it until you get the real success with the probability and impact analysis. So that way, you're addressing two things. One, you are improving the probability of the test cases that you are doing, and second, you are improving the probability of the overall root cause analysis and making sure your RBT is successful. And the next use case is leveraging AI in the UAT production analysis. One of the common problems that we hear a lot is how do we leverage something that whether it is existing or non-existing from the production, or identify the user patterns in the production and mimic the same in the actual lower environments. So with AI and ML, you could actually deploy those algorithms in the production and then keep using those in the lower environments so that you have the real production analysis and you could actually mimic the real user analysis from the production into your lower test environments. That's a great savings, and it would improve the overall quality of your testing. So with that said, the overall dynamics of the test methodology is changing around leveraging AI. Everything that we are thinking has to be done manually. So we could actually automate it to a greater extent. So the amount of automation can be increased by leveraging AI, thereby minimizing the manual intervention, and also, thereby improving the overall quality. So with that said, actually one of the interesting articles that I read is about the levels in which AI can be improved. With no autonomy at all the way to full automation, where AI would actually take a look at But the current maturity and different apps that are in the market, they're somewhere around level 1 and 2. But I'm pretty sure a couple years down the road, we will reach level 5, where the tools and the platform would be truly autonomous. But by leveraging AI and QA, we could definitely enhance the overall design scripting time and maintenance time. Thereby, we could save probably anywhere from 20 to 40% of time that we are spending on QA. And most important thing is we could continuously learn and recalibrate as required, so that we could be more efficient on an ongoing basis, and we could be more accurate, could increase the test coverage, and thereby improving the overall cost of quality. Having said that, there are few potential players in the market who are offering this as a service and as part of the platforms. So some of the tools in the market are Autonomic, Functionize, and Apply tools. And we are partnered with some of these. And today's focus is going to be around Autonomic, and who are one of our partners in this space. And we will talk about in detail on how we do what we do from an Autonomic standpoint, and how Autonomic could help leveraging AI in the software industry and in the software side. With that said, I will hand the presentation over to Raj, and Raj will talk from now on, and he will talk about in detail on Autonomic. Over to you, Raj.
Thank you, Siva. So I hope you can all see my screen. So from day one, our primary focus at Autonomic has been the enterprise. When you look at a typical enterprise today, their software portfolio consists of digital apps, maybe it's a B2B, B2C e-commerce apps, and SaaS apps like Salesforce, Workday, ServiceNow, Oracle Cloud apps, even SAP apps, and so on. So our application, our solution can test all of those, the entire software portfolio. We also recognize that the typical enterprise has embraced DevOps. They have CI/CD tools like Jira, Jenkins, and so on. So we already have integrations to those. We understand that when you think of a tester, there are many different roles within testing organization. There are business analysts, test analysts, SDETs. We support those distinct roles. We look at testing in terms of planning, execution, and analysis. When you look at planning, there are activities like test case creation, test script generation, test data management. Those are key areas in the planning phase. And in the execution phase, when you have to deal with cross-browser, cross-platform, continuous testing, concurrent testing, we support those things. And during analysis, you definitely want to understand change impact and be able to do smart maintenance. Also, you want to understand, you want to get some good reporting and deep analysis. We support that. In a nutshell, what you're seeing on this screen is how Autonomic can meet the testing needs of a typical enterprise. Our products consist of the following capabilities. First thing is we recognize the test case creation process is very manual and can take a lot of effort. And we have reduced that. We accelerate the test case creation. We automatically generate the test script from English test case. So somebody could write a series of steps that is part of a test case, a part of a test suite. We can take that, automatically generate the test script. That test script is executed within an instance on a highly scalable continuous test execution platform. We can bring up as many combinations of OS browser and execute all of them concurrently within minutes. Smart maintenance is a big challenge, which is a big capability that addresses a huge challenge enterprises have. Maintaining existing scripts, especially when you have scripts that are thousands of scripts in your library, maintaining that huge burden. We automatically do two things. One, we call auto healing, where we can automatically adjust your scripts to any change in the application in terms of object locators and things like that. The second thing is, if there is a business logic change, we can also handle that. I'm going to do a quick demo. So what takes hours is done. If you look at the top part of this slide, you can see test case creation, test creation, test script generation. Some of these activities can take hours to days. And what we try to do in the phase autonomic, our solution delivers all of those things in minutes. Let us do a deep dive on script maintenance. The very first step is creating the asset. When you create an asset, like a test asset, like a test script, that can take many, many hours to do, depending on the size and complexity of the test case. When you look at a change to the application, there are two types of changes. One could be object change, which is object locators change, object ID change. For example, the expat changed. That is a problem. And you have to manually manage it today. Or a business logic change. So today, what takes hours and hours, autonomic can do in minutes. In some cases, it doesn't even take time. For example, for an object ID change or a object expat change, we automatically heal it and you don't even have to know it. For business logic change, you will have to, a human has to approve the change, and then the change is percolated across the entire test portfolio. And here is a little bit more detail on the different aspects of smart maintenance. Here is a simple test case study of what we are able to do. We actually measured this for a particular customer, and what was taking them more than 4 to 5 hours, we were able to do in a much shorter time. As you can see here, this is creating the automation. Maintenance was dropped also dramatically because there was self-healing and smart maintenance involved. Number of automation engineers reduced. Time to regression testing reduced. And the most important thing is the net of it all, the feature velocity. That's what companies want. That's what enterprises want, is the feature velocity improved. Because now you can use this to test a lot of software much faster and quicker. So that means the developers can use their time in more feature development. With that, let me jump into the demo. When you log into our application, this is what you see. You see a project view. This is we call project view. There's also a dashboard view, but we will, in the interest of time, we will go into the project and we will dive into the different capabilities here. So, as you can see, in the project view, I can do several things. I can go ahead and create take an existing test case and automatically generate test scripts from it. In order for me to do that, all I have to do is I have to, in this case, for the purpose of demo, I'm going to have to upload a test case. But once it is installed or once a customer is provisioned, this can be done directly from their test repository with no human intervention. So I have uploaded a test case. Now I'm going to go ahead and upload a data file for the case. Industry best practice is data-driven testing. That's what we support here. And the moment I hit submit, the autonomous platform, which is our core product, takes over and starts generating, start processing the test case, exploring the application to make sure the test steps make sense in the context of the application, and generating the test script. All of those things happen within seconds and just a minute. As you can see, the platform has taken over. From here on out, everything, including test execution, evidence of execution, everything is fully automated. as a tester, I don't have to do anything more. My only job was to submit a test case, and the test case was defined, created this way. A test analyst created a test case for Salesforce testing. And even though for this demo purpose it's simplistic, but it doesn't have to be simplistic. It can include all kinds of verifications, assertion, API testing, loops, all kinds of capabilities exist in the platform. For demo purposes, I've chosen a test case. So this was created by a test analyst who wanted to actually test the part about creating a new lead in Salesforce and populating the lead. That was the purpose of the test. So as they were writing the test case, they made a few errors. Company was misspelled, annual revenue was misspelled, and they could even write compound statements like enter username, password, and click on login. And our platform does not, first of all, our platform does not require a keyword approach. You can write it in a free format, it will handle it, number one. Number two, if humans make errors, we can also deal with it. So these were the original steps. Let us go see how the platform handled it. So the platform, autonomous platform, understood that this particular statement had to be broken into 3 steps. Enter username, because there were 3 distinct activities. Enter username, password, and login. And you can see that here. And every step it executes, it generates an evidence of execution. Evidence, basically, is a screen capture with a highlighted, step that shows what exactly it did. For example, if you click on this screen, you can see here, city, enter city, data value was San Jose, and that's what happened here. You can see it in the red box. So once the testing is complete, the script, now the processing is complete. So script is generated, and an execution begins. You see here, this is executing this on our continuous testing platform. So actually, I don't even have to do anything for it. It is all pre-wired, and it is like that. Now, let us go take a look at the test script. And this is the test script we just generated. So this, I will scroll through slowly so you can see it. So this has a significant amount of working Selenium code. It's about 1,100 lines long, and if you look at how it is generated, you can see the details of it. For example, open website was one of the statements. Enter username was one of the test steps. Enter password. It's all commented in the code, so you can see and you can go in and edit if you need to. By the way, everything we generate can be downloaded and into your repository. So you don't have to have the test assets in our cloud instance or an on-prem instance. So as you can see here, some of the errors we have made, like enter company. Well, company was misspelled, but it found the right company on the application, and it populated that. And annual revenue was misspelled, as you can see here, and we have an intelligent match. It found the right annual revenue. So things like that. So now that it has generated the test script, the execution has begun, and once the execution is complete, we can go see the evidence of execution. There are 2 types of evidence of execution. One is a report. I did the same test a while ago, just in the interest of time. So you can see here this report. When I click on this report, it downloads a report that is more of a capture of every step that you can see this here. So every step that was executed is captured here, and the timelines and the timestamp, and then what exactly it entered and so on. So you can see this is more of a detailed evidence of execution. Then you also have a dynamic evidence of execution, which we can see here, which is, you can see here, when I click on this, we get a video, and this video actually shows what exactly happened. So it opened up Salesforce, it entered the user ID and password, and then it went into the leads tab. And in the leads, it went into new leads, and it created a new lead. And you can see here annotation of every step of execution. So we are providing multiple ways of sharing evidence of execution for compliance purposes. So this is one of the ways. So in the interest of time, I'm going to move on to smart maintenance, which is essentially a way of identifying a change and fixing it automatically. So we have a sample application, and this application is for purpose of creating loans. This sample application, somebody made a mistake while they created it and entered a wrong label, and the label is called that. And the label should be actually first name. So what we're going to do is we're going to make the change to the label in the application. So the test cases are written today to work with the label which is incorrectly created, because that's fine. Now, what we're going to do is we're going to show you the app. This is the app, as you can see here. That's fine is the label, and that's a wrong label. We have to make a code change and do a new build and fix this problem. And we're going to start with that. So we're going to go into Git, and we're going to go into our code file, make the change, commit that, and then do a new build and push it. As you can see here, so the activities that are happening. And within a few seconds, our application is updated. The label is changed from that's fine to first name. And this is reflected in the app. But the test cases are still pointing to, you can see here, the label has changed to first name from that's fine. But the test cases still have the old label. So what happens is when you push the build to, this is Jenkins, we're in Jenkins, we are integrated with Jenkins. So when you push the build, the test cases are automatically executed and they both fail. When they fail intelligently. They, as you can see here, we're pushing this, and you see the test was already run, and both tests failed. And when you look at the failure code, and it tells you why it failed, you can see here, label has been changed from that's fine to first name. Our platform detected the change and flagged it. Now, where it comes in real handy is not only does it know the changes occurred, and it has occurred in many places, in many test cases, but it also now provides you a smart maintenance capability where it lists out all the test cases that have the same problem and gives you an option to fix them all in one shot or individually. It is showing you the error code, and now with a single click, this is the option you have. If a test analyst says, yeah, I approve the change, and the change is made instantaneously. You can do it one at a time, or you can do all of them in one shot. So essentially, in a smart maintenance, what we're doing is we're doing a couple of things. One is we heal things such as XPath changes, CSS selector changes, those kinds of things. We automatically take care of those. When there is a change, a business logic change, we will flag them for you. Once you approve it, we take care of it. The maintenance burden can be as high as 30 to 40%, depending on the context, depending on the amount of scripts that are automated. That can be dramatically reduced using a solution like this. That, in a nutshell, is our demo. And now we can open up for questions.
Sure. Thank you, Raj. Couple questions that came up. The first one is the comment was the test case that is the basic one, but how do you handle looping and sublooping? And is that possible? And how do we even do that through NLP? How do we have to write?
Yes. So yes, it is possible. If you click on the question mark, and it takes us to a place where we have all the documentation, and here you can see all of the different types of commands. Verifications are possible. A loop construct is basically defining a block. You can do a switch command, as you can see here. You can use user-defined functions, and you can do all the API testing you want. We also have the ability to select certain things, and you can do hover, those kinds of commands. And also there is random variables you can you'll need it in certain situations. We also have this concept to answer specifically your question: beginning a block and ending a block, and with some instructions in between, is a very simple English construct, and then using it for a loop. You can run this for a number of times, for all the rows. All of those things are possible. These are all the commands that are available. So what we have done is, for those sophisticated users who want to do complex things in a test case, you're welcome to do it. And we have a bunch of these types of capabilities that are built into the platform.
So thank you, Raj. The next question was, how do we handle looping from a data standpoint, more from a data-driven? If you could open the data file, that's just another question, to share the data file.
Yes.
And then how do we enable data-driven testing?
Yeah, thank you, Siva. So the way we have designed the platform from day one has been to handle data as a separate runtime, binding the data and the script together. So if you look at this is our typical data files, and the data files have a complete separation from the test script or test code. So the top row, this is a simple spreadsheet that is imported, and then we can use a spreadsheet. We can even call, if you want to call us a database, tables to gather the data, we can do that as well. We have the full capability to do that. Now, the top row is the labels of what you are expecting, and the second row you see is the value. For example, due date, this is the value. Email, this is the value, and so on. So this is where this is how it is constructed. Now, to data-driven testing, you would add more rows to it. You would add more rows to it, and then by adding more rows, you are basically looping through all the possible paths that this test case can execute. And that's how we do it. You can do positive, negative testing. All of those things are possible using this approach.
Sure. Thank you, Raj. Next question is around parallel testing, and how do we enable and our features around that?
Yeah, that's a very good question. If you go to the script section, we have a parallel execution platform built in. If you look at this, what we can see here is the ability to select any number of OS. For this particular instance, we have just limited to 2, but there is really no reason why we cannot create 100 instances of Windows and Linux, different versions and so on. So that is something we can very easily do, as well as you can select any number of OS. Once you select them, you can easily run them in a concurrent mode. And that's how this platform is designed for.
Thank you, Raj. The next question is, how does the smart maintenance work for non-web applications? Do we even support that?
So that's one of the things today. We are primarily focused on web applications. When I say web applications, let me be very, very clear. When I say web, it is not only web, it is also all of the different types of flavors of it, right? There is SaaS applications, there's cloud applications, all of those things we can do, including API testing. So what we do not do today is the client-server applications.
Sure, Raj, thanks for clarifying. The next question is, how does how do you generate test case in the platform? I think you've shown that, but if you could show the place where the code is generated and the recording, probably that would help.
Yes. So that's a very good point. So here is the way you capture the test case and create the test case within seconds. So, for example, when you look at this is the test studio. As soon as I launch the test studio, it is smart enough to know it has to not only open up my test studio, but also my target application. In this case, my target application is Salesforce. So what I'm going to do is I'm going to enter the right username, and I'm going to enter the right password and log in. And as soon as I log in, it takes me to Salesforce. And in Salesforce, I can navigate. And so last time we did the testing of leads. This time I'm going to go ahead and create contacts. I'm going to create a new contact. So we'll create a contact with some pre-fills. I'm just going to add a few more fields. And then we're going to go ahead and save it. Let us pretend this was our test case. So if you do that, then what has happened is, in the meantime, everything I've entered has been captured in English in our studio. And as soon as I save this, it will go ahead and generate the test script, and the test execution happens like it was in the prior situation. In this prior situation is when I uploaded the test case, will be the same thing. So essentially, there is a very quick and effective way of capturing your actions, converting them into English, and with data separation and creating scripts and executing it.
Sure, thank you, Raj. The next question is, how do we run test cases or script test cases that require data from intermediate sources, and also test cases that take data from first test case and pass on to the next set of test cases?
Yeah. So just to recap that, I think there are two questions there. One is, how do we get source data, not just from Excel sheets, from other sources? That's one. The second one is, how do we carry data from one test case to another case? So the first question, today we have ability to query during execution time, ability to query a database, bring the data, massage the data, and use the data in the right way. So that is one clear capability. The second capability is we have a concept of variables. A variable is where I can actually save a particular intermediate output. Let us say you're running your test, and you have to save a policy number or a account number as a variable because you want to use this in the next test. You can do that by simply naming a variable and saving this value into that variable. So that variable is just like a programming concept. That variable can be then used downstream in another test or in multiple tests downstream. So that is how we retain some of the key values that need to be used elsewhere.
Sure, thanks, Raj. Few more questions. Again, there are lots of questions coming in, and we'll try to address as many as we can. And if not, we'll get back to you individually, each one of you, and answering each question. But a few more questions, Raj, since we still have time. One question is, where is AI being leveraged in the autonomic platform, and what are those instances?
So there is many places where AI is being used. The first, obviously, in the demo, I couldn't show all of it. The first instance is the domain-specific NLP. We are using that. And then also for object classification, when we do the application exploration and application discovery, there is some object classification that's happening. We're using computer vision, and we are also using, there is this capability. I'm not showing you yet because this is coming soon. In the near future, we'll be able to automatically generate test cases. There is a significant amount of intelligence that goes into generating what is semantically valid test case. Generation of test case requires a lot of AI capabilities simply because It is not. I mean, it has to be semantically valid, and that's another area we're going to use it. So I would say in summary, there are 3 or 4 places across the board where we use AI, and that's been our design from day one. We have deep experts in the AI field, several people with PhDs in the AI domain and also testing domain that work with us. So that's how we've been able to do this.
Sure, Raj. And the next question is, do you support API testing?
Yes, we do API testing today. In fact, in earlier conversation I was sharing, there are situations where you could just call a bunch of APIs and never have to call the UI, because we support the API testing.
The next one is, can you import existing test cases from other tools like Selenium, Protractor, Postman, etc.?
So we can, typically test cases, typically in an enterprise, test cases are in a repository, test scripts are in a repository. So our customers, and also results are in a dashboard that the customer has already picked. So what we end up doing is we end up picking the test cases from wherever the test cases are. If there is a test case repo, we can easily, take the test cases from there and through APIs and so on and bring it in and generate the test scripts and then put them to the test scripts repo. In some cases it is Git. In some cases it could be TFS or some other, source. And then we also can publish results. We have a dashboard, but sometimes customers prefer their own dashboard, which they've already, selected, and we will have to, we essentially support that, where we export the data into their dashboard, and that's how we complete the end-to-end support for the enterprise.
Sure. A few more questions. One question is like, I know you partially covered it, but reiterating that the test cases still need to be written. Do they automatically navigate through all the paths and design test cases automatically without users developing the manual test cases in the first place?
So today, you can see here, today there are 2 ways you can do this. One is a test analyst has created the test case, which we can take and convert it into test scripts. The other one is using the test studio, you can generate the test script. Or you can create the test case from which the test script is generated. In the near future, we will have more capabilities where by just understanding your application, we can automatically generate the test script, a test case, and the test script. So that is coming up in the next release in a few months.
Sure. One other question is, can you import test cases from Worksoft, HP Quality Center, TFS, and then execute on the platform?
So there are 2 questions within that. One is, can we import test cases in English? Yes, we can do that. If they're in Selenium, we are working on that capability where we can take an existing test script that you already have created through other means, not through autonomic. So that means we are working on taking those scripts and then bringing them all for concurrent execution, for speeding up your regression testing and speeding up your smoke testing, that kind of stuff. So that is underway. That feature should be available in the next month or so.
Sure, Raj. There are 2 more questions, but I think in the interest of time, since it's there is only 1 more minute left, I will conclude the session here. And to all the participants, thank you so much for attending today's session. It was a pleasure having you all, and we will get back to you with all the questions that were posted, individually responding to each one of you. And if you have further questions, please do send your questions to us. You will receive an email with a link to this, recorded link to this, webinar today. And you will also have an email ID with it. Please send your questions. And also there will be a survey right after that. Please do fill the survey so that we could conduct more sessions like this in future. and bring you more and more tools and trends from the market to help you better and to make you part of your success. So please send across. Please fill in the survey, and we will get back to you. Once again, thank you so much. Have a nice rest of your day. And that concludes our webinar today.